In today's section, we check we define the program of circular queue. Okay, in last section we have seen the program of normal simple queue, and in that simple queue we have seen insert, delete, and display function. Same way, in this also, in circular queue also, we'll see the same function: insert queue, delete queue, and display. Okay, so for that purpose, we have taken here three libraries: stdio.h, onio.h, and the size of the queue. Okay, we have taken three functions: insert queue, delete queue, and display. In insert queue, we have passed two parameters: integer, and one is integer with length and another is simple integer. Then delete queue, we will again pass the parameter, and in display queue we will again pass the parameter. Okay, with insert function will insert or will add the element into the queue. Circular queue, with the delete queue options or with the delete queue function will delete the element from the circular queue, and with display function will display all the elements which are present in the circular queue. As you know, circular queue, how we will define the circular queue? Circular queue's last element, that is the rear, will be referred by the front. The rear element will be referred by the front. In that case, the queue is circular queue. In simple queue, the front is different and the rear is different. The rear cannot refer or cannot point out to the front in normal queue, and in circular queue, the rear node or the last node of the queue will refer to the first node. So that's why the queue is called as circular queue. Okay. So in circular queue, there are three functions we are performing: insertion, deletion, and display. So for that purpose, we have taken three functions: insert queue, delete queue, and display queue. Then first of all, we have to create a null queue, that means a empty queue. For that purpose, we have written here in front is equal to minus q and in rear is equal to minus q. That means at the first position, or you can say at initially, the circular queue is empty. There is no node available in the circular queue. So for that reason, we have written here front is equal to rear is equal to minus 1. That means front is equal to minus 1 and rear is equal to minus 1. That means the queue is not present at all. Now again we have to create the queue. So for that purpose, we have taken the main function. In that main function, we have taken two variables. First is n and second is ch. N we are taking for the number which we have to insert into the queue, and ch is for the choice. Because this is choice based program, this is menu driven program. So for that purpose, we have taken here as a choice variable. Then after that, int queue size, that means the size of the queue, or we have to create the size of the queue. So for that purpose, we have taken the variable queue and with the size. Then in do while loop, we have to take the choice from the user, and for that purpose, we have written here printf circular queue. Then the options or choices which we want to give to the user, that is the insert, delete, display, and exit. For insert, the user will press 1. For delete, user will press 2. For display, user will press 3. And for exit, user will press 0. Okay. Then we have to give the message to the user that the enter choice between 0 to 3. That means the choice is between 0 to 3. Then the scanf, with the scanf, we can get the input from the user in ch variable, and in ch variable, and that ch variable will put into the switch case. The case 1 will be if the user will enter 1, it will call the insert queue function, and with that insert queue function, the queue will be created, and the new element which the user wants to insert, that will be added to the queue. And case 2, delete queue, the front element of the queue, case 2, the front element of the queue will be deleted with the delete queue function. And case 3 is displaying all the variables, all the elements of the queue in the display function, which are the elements are present in the circular queue. And this thing happens until the choice is 0. Until and unless the user enter 0 choice, until and unless the user will enter 0 choice, till that moment the loop will execute. Okay, and when the user will enter 0, the program will out of the memory. Then let's start with the function. First function is insert queue. Insert queue means we have to insert an element into the circular queue. So for that purpose, we have taken here in queue. That means we have to create a queue, and then we have to add the item. That means we have to add the number into the queue. So for that purpose, first of all, we have to check whether the queue is full or not. If the queue is full, you are not allowed to enter the element. So for that purpose, we have written here if front is equal to 0 and rear is equal to size minus 1. Okay. At first, the size will be 1, or you can say if the node is present, the size is present. So if the front is equal to 0, means if front is 0 and the rear size is size minus 1, that means suppose your queue size is 5, and as you know the queue is starting from 0 to n minus 1. So if the starting is 0 and the rear is minus 1, n minus 1, that means size minus 1, that means the queue is full. Or front is equal to rear plus 1. That means if front and rear notify the same, that means also the queue is full. So if this two condition is true, then the queue is full. You cannot insert the element. Else, if the queue is not full, you can insert the element. Else, if rear is equal to minus 1, rear is equal to minus 1. If the place is there to add into the queue, add element into the queue, the rear will also get updated and the front is also get updated with the plus 1 count, that is the rear plus plus and the front plus plus. Else if the length of the queue, if the topmost position of the queue is minus 1, size minus 1, that means if the queue is already present, that means if else size rear is equal to size minus 1, that means the rear is at full condition, that means, and the front is greater than 0, that means a front is greater than 0, then we have to add the new element, that means the space is there to add the element, and for that purpose we have written here rear plus plus, that means the new element will be added to the circular queue, and the rear will be added, and then that item will be added at the rear side of the circular queue. So for that purpose we have written here rear plus plus. Okay. Now after inserting, we have to display the elements of the queue. So for displaying purpose, we have written here the display function, and in that display function, we again display in the circular queue, means which are the elements are present into the queue that we have to display. For that purpose, int queue, int I, printf slash n, that means the new line, at new line, the element will be displayed. So if front greater than rear, if front is greater than rear, for that purpose we have assigned a for loop I is equal to front, I less than size, I plus plus. Until and unless the rear is n minus 1, until and unless the rear is n minus 1, that is size minus 1, at that, up to that moment, up to that stage, the front will be updated by I, and that I will be displayed, in this queue. That means after every iteration, the front will be updated as an I, and the I will be displayed in the loop. Okay. If Again, the second loop is for I is equal to 0, I less than is equal to real I plus plus. The second condition is if the element is started with a 0, if the uh, location is starting with a 0, and if it is starting with a 0, and if that element is less than is equal to real, is less than equal to last element, then the q will be again displayed, the I will be added, the rear will be added to the I, and that I will be displayed through the printf function. Then else, if for I is equal to front, I less than is equal to rear I plus plus. That means I is equal to front. That means the first element is added in the I, and till the rear is added to the I, till the rear is added to the I, it will be incremented and the loop will be displayed all the elements into the list. Okay. So there are three cases. First case is we will check the size of the array. Means if we define the size of the array, so less than the size of the array, when the I will get n minus 1, at that stage it will stop and it will display all the elements. Second condition is it will check the rear position. If it will get the rear position, it will hold the element and it will display all the elements. And the third is if the front is different and the rear is different, it will check the condition up to the rear point, and then it will add it all the elements to the queue and display the all elements. Display all the elements, and the last element is your void delete queue int queue in queue. There are three cases. The first case is queue is empty. If the queue is empty, front is equal to minus 1. It is indicated by minus 1. So if the front is empty, your queue is empty. So you don't have any element to delete the queue. Okay. So for that purpose, we have written here if front is equal to minus 1, means if the queue value, if the queue length is minus 1, your queue is empty. If the front is equal to rear, if the if the circular queue has only one element, if the circular queue has only one element, and we have operate the delete queue operation, then that element will be deleted, and again the queue will be empty, because in that queue only one element was present and that element is deleted, so the queue will be empty. So front and rear both will be minus 1. So this is the second condition. And the third condition, if the queue is present, if the queue has more than one element, if it has more than one element, then the first element, that is the front element, will be deleted from the queue, and the new front will be allocated by the second element of the circular queue. So the front element will be updated as a second element, and the front element will be deleted from the queue. So in this three way, you can delete the element from the queue. Let's check the code. Okay. So see here, enter the choice from 0 to 3. Okay. So we have insert here 1. Enter the number. I have entered the number 22. Again, I want to insert the data. Again, I will add the new element. Again, I want to insert the data. Again, I add the element. Now check the element, that is the display queue. We have to display the circular queue. We have pressed here three options for displaying queue, and these three elements which we have added into the queue, that are displayed in the display with the display function. Displayed with the display function. Now suppose I want to delete an element. Suppose I want to delete an element. So the first element will be deleted from the queue, and for that purpose we have entered second, and the 22, that is the first element, is deleted. The first element is deleted, and the rest of the element we can check with the display function, that is 44 and 99. The two elements are present, and the first element 22 is deleted from the queue. So this is how your insertion and deletion and display function works in a circular queue, like a same like a single queue, or you can say a normal queue that is working like this only. But in circular queue, the last element is always referred to the first element, so that's why the element is called as circular queue. Now I press 0 to exit the code. So with 0 I can come out from the code. So I think you have understood the you have understood the so I think you have understood the program, that is your 4D program of data structure implementation of circular queue. Thank you.